This video is going to go over how to solve quadratics by factoring. So in the previous lesson, we kind of reviewed factoring. Well, here we're going to actually factor and solve using factoring. So I'm not going to go over a ton about factoring because if you're still struggling with that, make sure you review the factoring notes. But factoring notes say it has to be in standard form. Standard form means I have to have ax squared plus bx plus c. The goal here is basically I want one side to equal 0. You want one side to equal 0. You want everything on one side. Now, what does solving mean, right? Solving a quadratic means you're trying to find the x-intercepts. Remember that another name for solution is an x-intercept. So if I were to graph this quadratic, I want to find these solutions, and the solutions are the x-intercepts, and I can find them by factoring. So the first thing I want to do is, again, I want to make sure that the steps here is that set one side equal to 0. Right, you want it equal to the number 0. Now, you want to keep the x squared term positive. So if it's already positive, don't move that, move everything else. So I know that the 3x squared over here is already by itself, and it would be way easier to just move it to the other side. But we want to keep it positive just so that we're all kind of on the same page here. So what I'm going to do is I'm going to move these two terms to the other side. I'm going to do that by first subtracting 19x from both sides. So I have 3x squared minus 19x equals negative 6. And then the next step here is I'm going to add 6 to both sides. Now, could you have done that in the same step and not have done two different steps? Sure. But I want to make sure we're on the same page, so I want to make sure we're there, right? Negative 6 plus 6 is 0. So now one side is equal to 0, and now I can factor. So the first thing I always check for is a GCF. I do not have one, so we're going to label our A, B, and C. A here is 3. B is negative 19, and C is positive 6. AC method, okay? A times C is going to be 18, 3 times 6, and B is negative 19. I need two numbers that multiply to 18, but add to 19, or negative 19. Is that correct? Negative 19? Yes. Okay, so I'm going to type those numbers in, hit submit. And again, this calculator is found in your Canvas page. So our two values are going to be negative 18 and negative 1. Does not matter the order that you do those in. So first term stays the same, and last term stays the same. But remember, this is still equal to 0. So I want you to write that equal to 0 because it is important. We are solving. Just because we factor does not mean we're done, right? This is solving by factoring. So it's one thing to factor it. It's another thing to actually solve it. So I write my two terms that I split, negative 18x and negative 1x. That's where these two numbers came into play. And then I factor by grouping. The GCF of the first two terms is going to be 3. I can take out a 3 from both and an x from both. So I have 3x. Take out an x there, has x left over. Negative 18 divided by 3 is negative 6. The x's cancel. Over here, my GCF is, well, the largest number I can take out is a 1. But if the first term of your group is negative, you must take out a negative. So the largest number I take out is a negative 1. Negative 1 divided by negative 1 is just 1, so I'm left with the x, and 6 divided by negative 1 is negative 6. At this step, your parentheses should match each other. And I almost forgot, equal 0, right? It's equal 0 the entire way through. Okay, so you put your GCFs into one set, 3x minus 1, parentheses, and then your matching set, x minus 6. Now, all we've done so far is factor, right? We have not solved anything. This is solving by factoring. The most common mistake is people will get to this step and be like, okay, I'm done. Like, no, you didn't. All you did was factor. You have not solved anything. So, the zero product property in math, which is considered this. I'll show you for an example. If A times B equals 0, then A equals 0, B equals 0, or A equals 0 and B equals 0. What does that mean? Okay, if two numbers multiply, right? If two random numbers multiply and equal 0, correct? The only way to get 0 as a number is if one of them is 0 or they're both 0, right? So let's say, for example, I have 3 times 0 equals 0. Then one of them has to be 0, correct? I don't get 0 by multiplying by 2, right? That doesn't work. So one of them has to be 0, or they're both equal to 0, and that's how I get 0. So when we're solving by factoring, you set your factors equal to 0, because this times this must equal 0, and we don't know which one's equal to 0, so you set them both. I know that was super long and worded. the goal is your factors, you set them equal to 0. So this first factor here, 3x minus 1, I'm going to set it equal to 0, just like over here, equal to 0. This second factor, I'm going to set it equal to 0 as well. And then I'm going to solve both of them for x. So how to get x by itself? Well, I would add 1 to both sides, and then 0 plus 1 is 1. And then I would divide by 3 from both sides. So I have x equals 1/3, or 0.3 repeating, but I prefer fractions. So that's one of my solutions. Okay, how do I get x by itself here? Well, I would add 6 to both sides, and I get x equals 0 plus 6 is 6. So here are my two solutions. So you're like, why did we do that? Well, let me type this in the Desmos real quick. I'm going to type this equation. Oh, this equation, the one that's in standard form, the one that we got ax squared plus bx plus c. I'm going to type that into Desmos, and I'm going to show you what we just solved for. Now, again, I said that solving means we're finding these solutions, and solutions with quadratics also means x-intercepts. So I'm going to go ahead and type in what we have. Now, I don't want to type in the equal 0 because it's going to look funny. So this is the quadratic that we're given, right? 3x squared minus 19 plus 6. Now let's tap on the x-intercepts here. Tap and tap. What do you notice? One's 0.3 repeating. What's another way to say 0.3 repeating? 1/3. The other one is 6. Isn't that the two numbers that I got for my answers? Yeah, we're solving for the x-intercepts. 1/3 and 6 are my x-intercepts. So that's what it means to solve by factoring. So let's go ahead and fill out our steps here. The first step is you want to set one side equals to 0, and if possible, I would keep a positive. Always keep a positive. The a term positive. Right? So even though it was easier to just move the 3x squared over, I want to keep that term positive. I don't want to make it a negative number. The second thing is I'm going to factor. Right? The first thing I did was I set it equal to 0. Once I did that, I started factoring using the AC method. The third step is you set all factors equal to 0. So, for example, I'll go ahead and label all of these. Step 1 was right here. Step 2 where we factored, that was here. Okay, we finished factoring, we completed that. Step 3, where we set them equal to 0, that's going to be right here. We set them both equal to 0, any of our factors. Remember, the things in parentheses are called factors. And the last step was that you solved for x. So I solved for x, and that's my final step here. So solve for x. All right, now I have a star down there, but I already wrote it up there, so keep a positive. All right, we have our second example here. Now this one only has 2 terms, but we do know how to factor, with just 2 terms. So I'm going to go ahead and do my first step. The first step is set one side equal to 0. Well, I want to keep that x squared positive. So I'm not going to move this because the 2 is already positive. I want to keep it positive. So I'm going to move this to the right side. And to do that, I would subtract. Because it is positive, I want to do the opposite. So on this left side, it's going to equal 0, and it's going to be 2x squared minus 4x. Once I get to this step, I always check for a GCF, and I do have one. What is my GCF here? Well, if I divide out a number, it's going to be 2 is the largest number that can go in both, and I can take out a 2x technically, right? I can take out an x from both. So I still have 0 equals, but I'm going to go ahead and start factoring. So I have 2x on the outside of my parentheses. 2 divided by 2 is 1. And then I have x squared divided by x, so I have 1x left over. Negative 4 divided by 2 is negative 2, and my x's cancel. And I don't have to write the 1 there. Now, once I get to this step and I look inside these parentheses, can I simplify x minus 2 and factor that even more? No, there's not really much I can do there. So, okay, what have we done so far? We've set it equal to 0, and we've factored. So we finished factoring. Next step is, number 3, set all factors equal to 0. Well, we have 2 factors still in this case. The 2x is a factor. So 2x is going to be set equal to 0. The x minus 2 is another set, so it's going to be set equal to 0 as well. So anything that you have that you factored gets set equal to 0. So just like the last problem, each parenthesis set gets set equal to 0. And now once you do that, what's the last step? You solve for x. So how do I get this one to get x by itself? Well, since it's being 2 multiplied to x, I would do the opposite and divide. Well, 0 divided by 2 is 0. So one of my solutions is x equals 0. Okay, well, how do I get x by itself here? Well, I would add 2 to both sides, and I get x equals positive 2. So my two solutions are 0 and positive 2. Now, how could I check this? I could type it into Desmos and see if those were actually my x-intercepts. In order to type it into Desmos, I want to type it in with just this part here. I don't want to type in the 0 equals part, okay? So why am I typing that in compared to this? Well, we want everything on one side. So we're going to type in 2x squared minus 4x. Okay, and if I tap on my x-intercepts, I get 0 and 2. And that's exactly what I got for my answers. So when you're solving by factoring, you factor and then you solve for the x. You're solving for your solutions to your graph, which are the x-intercepts. So that is solving by